All right, so we talk about the difference between fats and oils. Fats and oils are made of the same stuff. All right, we just tend to talk about fats as having higher melting points than oils, and that's pretty much it. You can read sort of these descriptions here that I have on the slide, but the big thing to remember is if we increase the number of double bonds between carbons, that's going to decrease the melting point. And so here you can start thinking about like bacon. When you cook bacon and you pour that grease into a jar, you're going to see some of it solidify and some of it's going to stay a liquid. Well, consider that one the oil and then solid the fat. However, those fats usually have low melting points. That's why they melt so easily. Here, this is from page 673. All it is a list of different cooking fats and oils that you're probably familiar with, and it gives a percentage of saturated versus monounsaturated, polyunsaturated, and then trans fats. All right. And you're going to see oils have a tendency, not all of them like coconut oil, but have a tendency to have more or a higher percentage of unsaturated uh, triacylglycerols. So we can start talking about reactions here. You guys can draw these. I've given you the structure for oleic, stearic, and linolenic acid. And you can combine those with glycerol. And if we did that, I could say, well, which of these products is going to have the lowest or highest melting point? All you have to really do is talk about how many double bonds there are. So here, if we look at that, two oleic and one stearic, in compound number two, there's going to be two double bonds. And that's it, because oleic acid has a single double bond. So this is going to have the highest boiling point. These three with oleic acid will then have the next, go down a little bit. And then linolenic has the most double bonds, so that will have the lowest. You could start talking about your diet. I think this is interesting because this is where we start talking about um, what is in things that you really don't want. So you can get these saturated triacylglycerols. Um, these have a tendency to increase serum cholesterol. These unsaturated ones, one or more cis bonds, they're liquid. These tend to decrease serum cholesterol. And then trans triacylglycerols are actually really, really bad for you because all this stuff tastes really good. What we can then do is start talking about the hydrolysis. And all we're doing is adding three waters to a triacylglycerol. We're getting glycerol off of it, as well as three fatty acids. That's how you digest these things. When you start breaking down fats in your system, you bust up those ester bonds. And you have glycerol, which jumps into your metabolic chain, as well as the fatty acid. So this is one you can break apart. We'll get three stearic acids. This is stearic acid that you'll get. And then here, there's other ones. What I like to do when I draw these is give you something like this, because that tells you how many carbons are in that chain. Uh, the adipose cells that you have, this is where we store triacylglycerols, and it's kind of a neat, it's kind of a wild thing. So one way to think about energy in your body is when you need energy now, that's glucose, sort of medium length energy, that's protein, and then your long-term energy, that's fat. Uh, these cells, the number that you have never change, but they change in size. These cells absorb these triacylglycerol, these fat molecules, and they swell in size. But if you exercise and start using up those triacylglycerols, those cells actually start to shrink, and as they shrink, uh, they're going to get smaller. And so one of the things that we do, you can see metabolism starts with hydrolyzing triacylglycerols. We're going to get this. We're going to bust it down. It's going to react with oxygen, and you get CO2 and water. And if you remember from regular chemistry, we could balance that equation. This compound is C57H110 and O6. And so you can see there's a lot going on here. We're going to generate a lot of CO2 and a lot of water, which means we're going to get a lot of energy off of